Hello everyone, can you hear me? All right, great. So we are starting now. All right. So before we start, so we talked about Bloom filters yesterday, and we can after that we were about to discuss what is co-processors. I think we discussed co-processors. We described what a co-processor can do on the server side. All right. A co-processor is just like your the server side triggers, which can be used in multiple kind of scenarios. Okay, you can define a pre xxx method as well as post xxx method. What is xxx method? Such as pre get. Okay, you can extend a coprocessor and create basically basically a controller or a handle by which you can restrict or do various kind of processing on the edge based side. Okay, for example, let's say you want to restrict some users from accessing some data. In those cases you create a coprocessor and override override here the way we have overridden override pre-get method. Okay, and here you can mention various kinds of restrictions, whatever you want. In case the user is allowed, then you simply return the value. All right. So, and in coprocessor, you can do multiple kind of things. For example, in case you want to put a monitor on one particular cell, that the moment this database table gets changed, we will trigger these things. Okay. For example, when people are adding data into a table, you can create maybe an index parallelly. Okay. So those kind of co-processor support is there in HBase. Now, after you have written this kind of a class to hand after you have defined and created a coprocessor, you can hook into the system either by adding this coprocessor into this configuration file like hbase config. All right, or you can basically, once you have defined, I mean, either you add it in the hbase config like this in this file by adding one property called hbase coprocessor region class, and in that you mention your package name and your name of the class comma the other ones, whatever coprocessor's name you want. And as soon as you restart your hbase, you will these classes will get loaded. Now there are scenarios when you do not want to restart your HBase. In those cases, this approach would be better. Loading from a table attribute. While creating table itself, you mention as an attribute that this table has got these coprocessors. And you upload the bytecode of the class there in the cell itself. For example, here we are saying coprocessor $1. We are saying coprocessor $1 and path and the class full name and the property. Okay, this way you can dynamically create coprocessor without having to restart your HBase. All right, and this we had already discussed, but okay. So any questions at this point? How do we define users? Yeah. How did we define users? Users are same as what you define in your HDFS, all right? As well as, yeah, yeah. So last slide we can discuss again. Okay. So the way whatever users, is the audio choppy for all? Okay. All right. So just a second. All right. So whatever users you create for HDFS, same users will be applicable for HBase. Okay, and you can basically create users from here. Alright, you can add a user. That user will become the user everywhere. All right, and similarly, let me see if HBase itself gives any control, but I don't think it gives any control from the command line. It assumes that only the HDFS users are going to access this. Okay. So yeah, so that answers Sarju's question. Now, with respect to this service, we had left it in between because our HBase was not up at that time. Now our HBase is up and is running fine. We can start our service. So we can start our REST service before we do this. Ideally, we should just start it on the boot time, and this can be configured from HBase config. So this is the memory that requires, and general, advanced. All right. This is our folder in the Zookeeper. All right, no worries. Here you have get and put. Fine. All right, so let me try to log in first and then we'll see anything else. Okay, so first thing first, let's start the HBase REST interface. This will start HBase's REST interface on 11111 port. Okay, so once you have done this, you can basically, let's see what all is there. First of all, we go to SSH. So this, on this we have started our service. It's basically a Jetty service, which is the REST interface. And here, here on this, we'll try to see the HBase shell. In the HBase shell, you can have a look. So what is the status? Three servers are there, 0 dead. Average load is 3.6. That is okay. And we say list. And our table was first table, say scan first table. All right. So let's just try to access, not like this, we have to say Hadoop1 dot no big data dot com colon 1111. Alright, it says table not found. Let's just put the correct table name now. It shows that the service is running fine. It is just that it is not able to find that particular row. Okay. So what we'll do is we will mention it here. That is our row key, and this is our column. All right. So as you do that, it returns a binary data with the column value. And what is the column value? Column value is this: col1, val1, right? Similarly, for the same row, if we try to access column 2, what happens is we say here, we say, what is the name of our column? Column 2. Uh, and actually, it did not remember our URL. Here again, this is our column 2. Now you can see that the value inside it is 1 2 3 4, which is same as this. Okay, so basically you can make a query to this REST service and it will give you the detail about. Okay, so HBase REST service does not allow you to do all of that. You can have a look at here. So it only allows you to do get and put. Okay, when you normally access something user using get http get, it will give you the data. In case you want to modify, you can modify using put http command. Okay, yeah, so in that you are right, it allows you to get and modify that database data, right? So the detail about exact syntax would is available under HBase Stargate. Okay, and yeah, so let me see if I can access this. Hmm? Yeah, so Santana's question is, once anybody knows the table name and column name, they can access it. Right now, yes, but in case you are not logged in, let's say you open an incognito tab here. The service may be insecure right now, you are able to access right now, but in case you want to secure it, you can further secure it. Okay, all right, so you can further secure it howsoever you want. Okay, right now this is completely unsecure, and there, while starting the service, you can say here there would be port, default port is there, and there would be a way to secure this service. Okay, so secure Stargate, very, yeah, it's a very very valid question. Not this one, we want HBase Stargate, HBase and Stargate. Okay, so all right, so it's a section 8.1 here. All right, So you can basically, in the Kerberos principle, you can basically secure using your usual Kerberos. All right. You can mention the Kerberos principle, key tab file, and that's the region server's key tab file, and then Kerberos principle and master key tab file and master principle. Okay. So once you mention all of these, you can secure your H-based client access. All right. Using Kerberos. So users can log in using their Kerberos credentials. Okay. Kerberos is a good way to provide single sign-on to all your services, and it works really well. Okay. Also in the HBase site, you can mention the authentication as Kerberos, which means that you don't have to you can mention that as Kerberos, which means whenever you start HBase shell, it will ask for login password as well. All right. So Anand's question is, how does Kerberos work? Is that your question, Anand? All right. So, all right. So I will try to describe it very, very quickly. Kerberos is of one way of making a single sign-on in an organization. So whenever a user is trying to log into somebody's service, the authentication and authorization is handed over to Kerberos, and once the user as the user comes to your service, user will be redirected internally to Kerberos, and where they will provide their credentials, and Kerberos will provide a session ID to the uh, user request. And this session ID in the backend, your services or say HBase services will verify against Kerberos. This whatever server you are providing for Kerberos, your system will call internally and check whether the session ID provided by the client matches with is really provided by this particular Kerberos server. Okay. So that is one way of verifying that if a user is coming to you with the login ID and session ID, then it is really, really valid. Okay. Yes. So Kerberos is a general single sign-on SSO, single sign-on process for any kind of services, not only HBase, but for any kind of service you are providing. And it's very basically, instead of you implementing login password this that, you basically delegate everything to Kerberos, and all you check is whether a user has a certain principal assigned to them, user has certain roles assigned to them, and that's all. Okay. So that is basically, whenever you are building any enterprise wide product, you never implement a login password things. If you are implementing login password, and how would you store password, how would you authenticate, that means that you are trying to write your own authentication mechanism, and that is going to hurt you really, really bad. Okay. So let me give you the example of document management system which we wrote. In that, what we had done was we wrote the whole service, we wrote the whole product, but we never wrote the login screen. The login screen was very much pluggable. If our B2B customer is providing their own authentication mechanism, we just redirect all the all the accesses to their server. Okay. Instead of Kerberos, you might want to choose NTLM, which is provided by Microsoft, or there are other services available for authentication in your network. But Kerberos is something which is well known and works with Windows as well as Linux. NTLM only works for Windows. All right. So basically, every B2B product can be should provide a authentication mechanism which is delegatable to a central scheme. All right, makes sense to you, Santana? Did that make sense to you? All right, great. So yeah, that was a very quick overview. That was a very quick overview of what is a single sign-on solution. And how do you generally do is that you do not build any logic inside your application. Okay, all you do is delegate everything to authentication and authorization systems. The way security works is you define authentication and authorization. There are two parts of any security system. Authentication means that this user is who he is claiming to. That is authentication. And how does a user authenticate is either by password or other mechanism. The general one is using password. So authentication is saying I am Sandeep Giri because I know the password of Sandeep Giri at Gmail. Okay. Next is this is authentication. Next is what is this Sandeep Giri allowed to do this in this organization? That comes from roles assigned to the user Sandeep Giri. Okay, so authentication is generally handled in Kerberos. Authorization is very subjective to each organization, and lots of people prefer to go with role-based access control for role-based access control systems in which basically we assigned various roles and all the applications just query that what are the roles assigned to a user, and then they take action based on what are the role assigned to the user. Okay, so role might be very specific to each application. All right, so that is how the security in B2B products generally work. So for role-based access control, people like to use things like Active Directory or things like LDAP protocol. Good. So this way we can access the service, and we can also try to do the put in case we want to change. Let's just try to do this if we can do. So let's see what is happening. Here we can say question mark value, and yeah, still no luck here. And yeah, so basically you'll have to do a put request. Okay, if you have wget, then you can say put and the URL, and then it'll work fine. Okay, you have to put instead of http this, you'll have to say put this equals this. All right, whenever you're calling something from the browser, it's always get, and whenever you're submitting a form, that's a post. So for put you need to use the special things on the protocol side. You can say wget minus help and know all the arguments here, and out of this you can say where is that method, where is the method for getting the data or putting the data. So http user is okay, password is okay, header there would be. All right, you can try to use any of the programming language also. Put using wget. So, okay, so you can actually do c curl minus t. Yeah, that's correct. So you can basically see here, right? Why does it? This gives just a second. All right. Yeah. All right. So yeah, basically you can use the command which Anand has given, but all right. So you can try that out with your either program or from the command line using curl for putting the data. All right. Should we move on? All right. Okay. So I didn't know that there's something called Postman. I'll take a note of this. All right. So yeah, good, good. I'll just take a note of this one. All right. So now let's move on to the next session. Good, good, good. All right. All right. So if we have to do, if there are multiple threads we want to run in parallel inside our Java code, Python code, or something else, what do we use? Anyone? If we are running two multiple things in parallel uh, on a machine, inside a Java virtual machine, what do we use? Yes? So nobody is from Java background? So, okay, let me rephrase my question. Probably my question is unclear. In case your Java code, there is one function which is reading data from hard disk, and other function which is doing some computation, and you want these two functions to perform parallelly. If you want the two functions to be performed parallelly, what is it that you use? Yes, we use threads, right? And for coordination between multiple threads, what is it that you use? So there is one thread which is accessing something, and there is another thread that is also accessing the same variables. We use various syntax of synchronization. Every programming language, whether it has threads or only processes, provides synchronization. Now, my question to you is, there is a synchronization keyword, meaning that multiple thread while accessing a piece of code while accessing a variable will be very very cautious if you provide synchronization keyword inside Java or in other programming languages as well. In C, we have something called monitors to to make the threading happen in C or C++. We create monitors, and in other programming language as well, the concept of threads is quite popular. Okay, now imagine this: there is a program which you want to run parallelly on multiple machines, and what that does this program do? This program accesses an inbox and starts processing the emails. Okay, this program of yours, what you did was you launched on 10 machines simultaneously, and all this program does is all of these instances will be connecting to the same inbox and will be processing the emails. Okay, will be processing the emails. Now, what do you want is, in case one email is being processed by one thread, you don't want it to be processed by another another node. So you have 10 node running 10 Java virtual machine, and you launched this piece of code of yours which runs on all these 10 machines to access some inbox. Okay, so is everybody on the same page? So let me draw it. I think then it'll look good and will make a lot of sense to you. All right, let's say you have one node. Okay, you have another node, you have one node, another node, and there are another node. Okay, and let me just try to take a risk. All right, now there is another machine which is containing multiple records. Record 1, let's call it inbox, and we call it email 1, email 2, and email 3, and so on. All right, now this is my inbox, and these are all of them are running my email processor. This is your email processor which you are running on all these machines. How do you copy it? Never mind. So these are your email processor, and what does it do is, let's say from here, all of them are going to talk to your inbox. Okay, what you realized is that email processing is too much of a headache, and what we want is each email processor to be run on, say, 100 machines, or maybe 10 machines for the 3 machines for this example. And what do we want is, we do not want two email processors to be processing the same email. So no matter what synchronization keyword you use inside each email processors, it is not going to help us. So how would you solve these kind of problems? Anyone? So the problem statement is, your email processor is all of these email processors are going to talk to the same inbox, and first one will pick up email 1, second one will also pick up the email 1, and third one will pick up the email 2. That's what we do not want. We want first one to pick up email 1, and second one to pick up some other email, third one to pick some other third email. right? So what is it that you will do to make it happen? So the question is clear. You wrote a brilliant program which connects to the inbox, processes each email for say for say spam protection or something, and then processes it in detail. It does a lot of churning such as language analysis and everything. And then it we do not want all the email processors to be talking to the same. Some rule, Santana is saying some rule in the main inbox server for handling it. Okay. Now inbox server is normal POP3 or say IMAP server. Okay. This is your this is your POP3 or IMAP. Standard one. You have no control over either of that. Yes, let's say we go with what is Anand saying, we can use timestamp. But these email processors need to be communicating to each other, right? How would you generally do this problem? I have in real life actually faced such kind of problems. That is why I'm asking you. Anyone? Yes, we can have a centralized task manager. Okay, what kind of task manager? Could you give me an example? So what he's saying is he'll have a task manager. Let me just color it differently. Let me make it black. All right. Which keeps all the processed record before taking any email, go through the task manager and then good, good. So, and the only thing email processor can do is mark the email read or unread. Okay, only after processing the email. All right. So basically, we'll have to use a that central service which says things like email processor 1 is right. Processor 1 is talking to or you can say email 1 with timestamp something is under process. Okay. Now, before picking the element, now let's call this whiteboard as under process, right? So what happens is every time you have these kind of problems, you invariably have to have something like a whiteboard where first email processor picks up an email, marks it that email one with this timestamp and this subject line, okay? Subject line is under process, so don't touch it. Okay, so email processor will pick an email and mark it here under process and start processing. Once the processing finishes, it will remove from here, from the under process whiteboard, and then mark the email as read instead of unread. Okay, now Next email processor comes in. Before picking an email, it checks whether it's unread or read. In case it's unread, it goes to the whiteboard and further checks, is anybody processing it, or is something being done on top of this email. All right. So just like in this example, we needed a central whiteboard kind of a service. So the first step is it goes this, and next is it reads the data and then processes it. All right. Now, this is a classic example of what you do when you need a coordination. These email processors need coordination because the thread wise synchronization is absolutely useless when there are two programs running in different memory space, okay, or there are two processes. If you are running two different processes and both are having thread safe synchronized keyword, there is no use of it. If even if you run email processor twice on the same machine, still it will be it will not be it will not be blocking each other. They will all be reading the same email, right? That is why you require certain other mechanism. So thread safety synchronization was good if there was only one process. Threads thread synchronization is only valid inside a single process. Okay. Now, to for process safety, what we used to do is we'll create a single email processor would create a file saying, I am doing something. Okay. I am reading this file, and this is in the if these processes on the same machine, they can all communicate with each other by creating local files, right? But when we talk about moving the process, moving the work not only outside one single process but to multiple computers, okay, so here we are not only talking about parallel computing or multiple threads, we are talking about multiple machines running the same piece of code parallelly. All right, because all of these copies of the same code, so they cannot differentiate with each other so easily. You cannot have different codes in this. All right, so this is a fairly common practice to use a central sort of a whiteboard where you write things. All right, so this email processor will also be writing in the same manner, and this will also be writing in the same manner. Make sense to you? All right. All right, let me just take a snap. All right. Now, this is what we call our normal coordination. All right. So, this whiteboard which we have described here is what our zookeeper is. And that's what we are going to talk about. Here, there are few things to note. First, this whiteboard need to be available to all these machines, like uh, I mean, it should be available to all the machines simultaneously. Second, it should be really, really fast. Third, it should update really quickly. And fourth is it should not need, we do not need too much of, we do not need too much of storage on the whiteboard. Okay, very small uh, storage will always work well. Okay, so this is one. All right. So this is what is we call a distributed coordination service. Okay. This distributed coordination, if you have only 10 nodes, if you have only 10 email processors, then I think MySQL kind of database will also be sufficient. But if your email processors is being executed on more than 100 nodes and it requires a sub-second feedback. Within milliseconds, you want the response from the server, as well as you want it to be available all the time. Then you would require a service like Zookeeper. Okay, instead of writing into this whiteboard which is in MySQL. Okay, so that whiteboard which is really available is Zookeeper. Okay, so Zookeeper is a distributed coordination service for distributed applications. So our email processor, which we distributed to all machines, is called distributed application, and something which helps you coordinate is called coordination service. A coordination service like Zookeeper exposes a very simple primitives, something like create a file with this data, or delete a file, update a file, that's all. Okay, so that's a kind of very simple interface. It's provided by Zookeeper. It is very easy to program too, uses a data model like a directory tree, used for synchronization and configuration management. So synchronization is one. Other uses of Zookeeper is saving a central configuration for all our processes. Like in email processor, if we wanted to control all the processes very immediately, we will let them load the configuration from central config system every time they execute. All right. So configuration maintenance is another game, because our email processors will keep running 24 by 7. So we might want to might to control the behavior of all of them through a central configuration. Okay. So such coordination service does not, this is a coordinate service that does not suffer from any race conditions and deadlocks. Can somebody explain what is race condition? Yes? Or you want me to explain what is a race condition? The deadlock is a different scenario, and race condition is a different scenario. All right. So the race condition, as we talk about, all right. Okay. So a race condition is, there are two processes, process 1 and processes 2. Both of these processes are competing. Okay. They both are competing in reading a file or writing a file. Let's say both are writing to a file. Okay, both are writing to the same file. Now you can imagine if there are two things writing to a file, and what will happen to the data inside the file? It will get corrupted. Okay, so a race condition generally leads to a corrupted data set. Okay, now imagine this. There was your ATM account. You took out the money. You took out. So when you take out the money, what happens? So imagine that there was int x is equals to 100 in the beginning. We say withdrawal amount y equals to 20, and we say the new amount int new amount is x. My the next is, we basically read read amount, let's say. Okay, this read amount led to 100 rupees at this point of time, and so in your account there were 100 rupees. All right. Now you take out some money out of it, meaning now you took 20 out of it, so it became x minus 20. Now you were very clever. What you did was you were in a room where there were two ATM machines. Okay, you inserted your ATM card in the parallel machine after l- logging into one machine where the amount was 100. Similarly, in the parallel machine, you withdrew 20 rupees. All right, in the parallel machine. So now at the end of it, when you withdrew from the second machine, the amount got reduced to 80. And here, if the logic is not correct, it will say save X. Okay, save X. Now, at the end of the process, your amount will be 80 instead of 60. Okay, there are two processes competing with each other. There is one process. So there is an ATM cabin containing two ATM box. You first logged into one ATM box using your ATM card. Now you took out the ATM card, inserted into the another ATM machine in the same cabin, and took out 20 rupees. Now, if this ATM machine is buggy, it has if it has the race condition, what will happen is, because it has already read the amount and now it is trying to save, it will save finally as 80, right? And that way the whole that way the bank got cheated because of the race conditions. All right, so race condition is something when two parallel threads can corrupt the data, or two parallel processes can corrupt the data, then there is a race condition. Okay, so race condition is probably one of the biggest security threats, and it's very difficult to solve such a security threat. Every shell script is inherently prone to prone to the race conditions. Why? Because we can pause the shell script execution at any point of time. All right. So, yeah. So, in these cases, when there are two people trying to take out the amount, we might need a central service, which does not suffer from any kind of race conditions. Yes, that's correct. Okay. So, although for race conditions, lot of things are provided in the JVM, but those are only good if there are two threads competing in the same JVM. If they're on different machine, the syntax provided by Java is completely useless. All right, that's where the zookeeper comes into play. This coordination service does not have any race conditions or deadlock. Deadlock is when A process is waiting for B process to finish and B process is waiting for A to finish. So it's a cyclic dependency, and this happens quite often in databases also. And you should be able to differentiate between race condition and deadlock. All right. So is this clear? The difference between race conditions and deadlocks are clear. Mark, Anand, great. All right, so let's move ahead. So here the most important part was to understand why do we require a coordination service. These are few design goals. First design goal is a shared hierarchical namespace that looks like a file system. So for coordination, As I was telling you that before the times, if there are multiple processes running on the same machine, we would create a local file, we'll write the data into that local file, and before doing anything, we'll read the local file and validate that we are not, there is nobody else doing the same thing what we are trying to do. Okay, so we used to have a local file system to help us coordinate with other processes. Okay, you will see that in lot of cases you will, there are log file, dot log file, right, saying in case there is one process running, it will just create a log file so that other process, if launched, will honor the log file and will not corrupt the data. Similarly, if your process is running on multiple machines, it makes sense to have such a file system kind of thing in the network, and that's what is Zookeeper. So it is a very simple hierarchical namespace that looks like a file system, and each, this namespace has something called Z node or Z nodes, which are similar to files or directories. The difference, the data is kept in memory and it's disk supported. Even if the server shuts down, there is a backup, achieves this high throughput and low latency numbers, and it's really highly performant, used in large distributed systems. Highly available, HA means highly available, means there are multiple machines running parallelly, running parallelly our Zookeeper, so that, so that even if one machine shuts down, there is no problem to any of the people seeking the coordination. Okay, and strictly ordered access, meaning synchronization. All right, now talking about highly available, Zookeeper is a replicated service, meaning there are multiple nodes having this service running, and so always there are multiple nodes running this service, and they present itself like a single machine. So the client, which is you, who is seeking the coordination between email processors, for example, will keep a TCP connection to Zookeeper and would keep on getting the watch events on various things. If there is some email processor which has come in and some email processor which has finished the processing, all of these can be the watch events. Okay, and it sends a heartbeat. All right, so the client stays connected to the Zookeeper service and keeps on getting the watch events. Client's duty is to keep on sending the heartbeats so that Zookeeper is able to notice that these clients are connected. In case the client does not send heartbeats, Zookeeper assumes the client has died, or the client's machine has got shut down and the connection breaks. All right, in other words, in other way, if a client is connected to Zookeeper service and that particular machine goes down to which the client was connected, automatically the client is connected to another machine. Okay, next, in the design part, the servers know each other, keep in memory image of the state, and logs and snapshot are persistent. All right, to keep everything ordered means synchronization. Zookeeper stamps each update with a number, and the number reflects the order of transaction. So every time you update something in Zookeeper, it gives it a number, so that one number and another number is always ordered, and hence this ordered access or synchronization is strongly strongly implemented. Other design goal of Zookeeper was fast, and it actually performs really, really well if reads are more than the writes. So the at Zookeeper cluster has been benchmarked at Yahoo, where it has been able to give you 10,000 operations per second for write dominant workloads. All right. Now that was the theory part of it. Let's do some practical here. So already we have our Zookeeper running. You can see the Zookeeper is running. It says Zookeeper server started. There could be multiple Zookeeper servers. Right now we have only one. And the first is to check the status. First is to check the status of our Zookeeper. These are four-letter commands. Okay. So you can simply say after logging into the server, you can simply say things like, "Are you okay?" And it says, "I am okay." Okay. What is it that we did here? We first we said echo "Are you okay?" which basically does nothing other than printing "Are you okay?" Then we piped this to NC, which is connecting to localhost at a port 2181. NC is like your telnet, okay? And we can actually try telnet also. Telnet basically connects you to this, and we can actually try to do this. Are you okay? See, it says I am okay. All right. Similarly, we could say things like conf, and it gives us the configuration. Sounds good? These are the basic admin commands to check statistics. Now, if you want to install Zookeeper, you can simply download it, extract it. The simple installation of the single node is fairly straightforward, but installing on a cluster takes fair amount of effort. So I strongly suggest you that keep use Ambari to install Zookeeper in your cluster. Okay, by default Ambari, when you select services, it will install the Zookeeper. Okay, sounds good. Now let's talk about the data structure. How is data stored? This is how you can visually represent the Z node. You can create a node with a path. Say slash is one node, slash Jew is one node, slash Jew slash duck is one node, slash Jew slash goat, and slash Jew slash cow. These are also the node. So there are in total five nodes. On so each node can have children node, as well as each node can save the data in it. Okay, each node can have children. Say slash is having children, slash can also have data. That is the difference between file system, and that is the difference between file system and any of the tree. Okay, so let's have a look at a hello world example. Let's boot our Zookeeper client. All right, now we are connected to Zookeeper. Okay, and these are the, so if you say ls, it will show you all the nodes at the top level. So these are the nodes which are at the top level. Okay, so is there a way to ls2 slash, yeah, all right. So this way we are able to see that these are the top level node. We can further say slash this, and under this we can see that there is nothing in this node. We can also say get, and it gives us the data stored in this particular node. Here the only data that is stored is x, and we can also say get this. It has no data stored in it, and we can say get slash kbd, that is the third node, and there is no data stored in this also. Also we can say 6th December, right? So here my class is the data contained in the node. All right, now let's try to create let's try to create a node here. We want to say it fab 28. Okay, so we say create this, and here we put some data in it. What data do we want to put in? Let's say Mark, Sarju, and Anand. Okay, this is the data we are putting. ls slash fab 28 has nothing in it, has no children node, but if you say get this, this contains this data basically. Oh, the data stored in it is not having the space. We can set the data. So let's say get slash fab 28. All right, now it has stored the data here and is able to work well. Okay, for some reason I'm yet to understand how come. So it looks like this client thinks that space is a separator. All right, so we were able to save the data into each node. Okay, so that is the basic get, put, and ls command, which are part of our file system, or you can say zookeeper z nodes. Okay, sounds good to you? So here the connected, as we say, these are the ordered access. Every command gets the number here. So in the previous command it was 18, then before that it was 17, and before that it was 14, 15, which means that we have executed close to 18 commands. No, only for this session. It does not record it anywhere. It does not record any history per se, just for this session. All right. So if you also log in parallelly from different machines, you can say easily zookeeper and say client, right? Here it starts with 1. All right, good. Also, there is no such thing called update operation. We always set the value of the node, or delete the value of the node. We never say append this value, just to keep the read and write access atomic. If it provided things like people can read and write simultaneously, some can append, then there would be a tremendous amount of conflict, and there are chances of race conditions. All right, now the z node, we talked about the basic infrastructure called z node, and the z nodes, or z nodes, they call it zookeeper nodes, are of many types. By default, when we said nothing about the type, it creates a persistent node. Even if we exit, or even if we stop this stop the zookeeper client, these nodes will exist forever. That is persistent. While there is another kind of node which is there called ephemeral node. Ephemeral nodes are ephemeral nodes are good for maintaining who all are connected. And basically, an ephemeral node is the node which will get deleted the moment the creator of the node goes offline. Okay, so if I create a node and close my shell, it should disappear after some time. So that is ephemeral node. Ephemeral is the momentary, or it will disappear after some time. That's the meaning of ephemeral. As soon as the client who created an ephemeral node disappears, the node disappears. For example, if we create under fab 16, we say create minus e. Okay, create minus e, and we say slash fab 18, and we call it sg1. Sorry. So if we want to do that, let me just copy. Also, if you do not provide data part, it will throw an error. So we can say this is ephemeral node. Okay, now this is my ephemeral node, and in case I go here and I say fab ls fab 28, I'll see one node called sg. Okay, which is my ephemeral node. Now after some time, if I exit from this node, okay, so I exited from here and I say this ls, for after some time this will get deleted. Okay, after some time, probably in 10-15 seconds, it should get deleted from here. Okay, so as soon as the zookeeper session ends or times out, the ephemeral node is deleted from zookeeper. Ephemeral node cannot have children, not even the ephemeral nodes. Okay, so ephemeral node cannot have children, and an ephemeral node is visible to all the users who are connected and have the permission to do that. Okay, now you can see that after some time it has automatically disappeared because the session who created this ephemeral node has disappeared. All right, makes sense. Even if the same user is connected elsewhere, there'll be different session. Okay, sounds good, Anand. Are you able to see that? Yeah. So Sarju's question is, what is the use of this node? Okay, we will talk about it in detail, and there are few more nodes coming in. We'll talk about them also. And Mark's question is, so it's how to push the same environment access or data to multiple users at the same time. Right. So that is the objective of Zookeeper. And the data model it provides is a kind of a tree structure, plus it provides you few kind of nodes. One was normal persisted node, second was ephemeral node where the node will disappear after some time. Okay, now third kind of node it provides is a sequential node. Automatically the name of the node is created in a sequence, and the sequence ID, the counter is per Z node. Okay, every Z node has got a counter, and you can, if you create a sequential node under that node, the name of the node is generated by Zookeeper based on the counter of the parent. Right, now let's create a node here called sequential node. We call it sequential, And under Fab 28, if we create something here, okay, we call it 1. So in Fab 28, instead of this, we can say, right? Now, if we said slash fab 28, it automatically took it as a prefix, and in the parent ID, it created the fab 280040 because 40 is the running count of the slash, okay, for the sequential nodes. Okay, you can see the, right, all right. Now here we can see it. So if we create one more, let's call it sequential node, and if we keep creating the node which we are creating here, they are all in a sequence. You see 0 1 0 2 0 3, and if we say we give a prefix, say let's say support request or req, so ls slash fab 28. So the IDs, the nodes which are being created, are basically in a sequence. Okay, so every prefix you provide, it basically suffixes it with a number, which is the running count of the current node. All right. If you create another node under Fab 28, let's call it sub, and just give it some name. So if you can see that Fab 28 has got one more node called sub, and under sub, if we try to create the sequential node, okay, the counter will again start from 0. All right. And if you keep creating the node with nothing as prefix, it will keep giving it only the number. If you want to provide some prefix, it will create the node based on the prefix. All right. So basically, the sequential node is a node that is created by only providing the prefix. Provided by Suffix is provided by zookeeper, and suffix is the current running count of sequential node under the particular node. Okay, so did it make sense, the sequential node part? Now let me ask you few questions. Fab 28 sub. Okay, now if I say create minus s and this, okay, we want to call we want to call xxx. We want to create this node. What will be the number? What will be the name of the newly created node? Are you sure? Because we are not, the sub already have how many? Up to up to 6, right? Sub already have up to 6. We are just creating another sub node under sub. Prefix we are providing xxx, so it will be xxx and then 0007, right? So sub already has a running count of 6. Next sequential node created under sub is going to be 7, and that's what we are saying here. We are saying create a node with the prefix xxxxx under this particular parent node, under this particular parent node. All right. So you can see that it has created a node called 7. So everybody okay with this thing, or perfect? So we talked about three syntaxes. One was creating normal node, second was creating ephemeral nodes, third was creating sequential node. Okay. We will talk about the usage of these things. Next is watches. Clients get notification when Znode changes in some way. While creating a node, we can also say that please notify me. Okay, when creating a node, you can say please notify me. Similarly, while getting the data from a node, we can also say please notify me. All right, and those are called watches. Okay, so we can get the notification from Zookeeper, and watches are triggered only once. For multiple notification, you have to re-register. You will be notified only once. All right. So programmatically, you can provide a function or which is your way to handle a watch. And then in that function, once you have handled a watch, you will re-register for some same watch or something else. Okay. These are the general operation. We talked about create. Create creates a Z node. We saw that. And if you want to delete a node, we can delete using a delete command. We can say delete, and we will just delete the sub. Okay, but it wants it to be empty. Okay, we have to delete one node at a time. All right, and good news is that you can press tab, and you can basically say 0, 1, 2, 3, and so on. Right, you can delete everything. All right, so you can delete the nodes, and also can test whether a node exists or not. We can say fab28, does it exist? And generally the ls is good here, but when you are talking in terms of programmatically, there is a syntax for exist itself. All right, and every Z node, because this is a shared service, there will be many kind of services talking to Zookeeper, and that is why the Zookeeper provides you the access control for everything. Okay, authentication as well as access control. You can say that this node is only available to these users. This node is only available to these roles. That is access control. All right. So it gives you a way to set access control and get access control. And get children gets a list of children of a Z node, and get data and set data updates the data. In our case, from the command prompt, it was get and set, and these function get data set data is equivalent from the programming language perspective. And also there is something called sync, which synchronizes client's view of Znode with Zookeeper. Okay, all right. And whenever say you have to update or delete 10 nodes, and make sure that either all of them delete or nothing deletes, okay, you can send out the batch updates together. All right, using this multi-update, you can actually implement transactions, and nobody else observes the intermittent state. Say you are deleting 10 nodes in a single shot, right? Nobody will see that only 5 are deleted and rest are being deleted. They will all see that all of the node just vanished together. All right. There are two kinds of APIs which are provided a zookeeper, and those two APIs are written in Java and C. Those are the main core APIs, and rest are contributed by various people. And as of today, Zookeeper supports lots of public APIs. Few of them which are contributed is Perl, Python, and REST. But it is very easy to actually implement all of this because the REST controls are available. All right. The important thing you should note is all these APIs provide you two kind of function to do the same thing. Let's say for deleting something, all right? So if you think about it, there could be two ways to do anything. Whether you want to delete data, update data, read the data. There are two ways to do it. One, I say that, okay, delete my data right away. I'll wait here till you delete the data. Okay. Second is delete the data whenever you are free, just that as soon as you finish, let me know, right? So both have their own advantages and disadvantages. One is called synchronous, other is called asynchronous. Synchronous is one where we say that I will wait for you to finish right away. You start deleting in synchronous manner and I am waiting here. I'll not do anything else. That is synchronous method. That is how we generally execute any function. Unless and until one command finishes, the control does not go to the next command in a file. That is synchronous access. In case you provide a handler and say that once you are done with deletion, please call this function. That is asynchronous. That saves us a lot of time, but makes our life a little complex in terms of handling all of these circumstances. Sounds good? So you always give callback function. This callback function is like a function handle which we pass to these functions, and basically whenever they finish execution, they will make a callback to your function. Sounds good? All right. So let's take a break for 10 minutes. Back by 10 of 14. All right. So, can you hear me clearly? Should we start? All right. So, there is a marks question. I need to just pick it up. All right. So, yeah. So, Mark's point is that he's looking for a simple end to end project that uses these components and and using some data he can try. All right. So I will try to provide you that. Although at the end of the project, and at the end of the session, which will be next weekend probably, we provide you a project which exactly contains this kind of things, where you can go step by step, try to do things, but that only involves HDFS and Hive. Okay, we could do something more. Maybe I can make a project out of Apache Mahout and then try to do things. Okay, so yeah, so I would strongly recommend to you whatever we did as a hands-on exercise in case of a hive and in case of pig, you should try to do that at your own, completely at your own, following exactly the same steps, looking at the video which we had at that time, and you will basically be, I mean, the best idea would be to actually try to do things whatever I did on all these four. First, I tried to show you how to copy file to HDFS from command line. After that, I tried to show you Hadoop streaming. Next was MapReduce. Then I showed you the pig examples and Hive examples, HBase examples. So first you try to do them independently. Okay. Once you are confident about it, then we can actually talk about things like Mahat. So we will basically try to do two things. One is build recommendation engine, or let me say build movies recommendations. And second thing we will do is build the sentiment analysis. Okay. All right. So we will basically try to do these two things, and then in these, I would take one approach. You might take your own approach. Either you use Hive or Pig, or you use Simple MapReduce. It will be up to you. Okay. Sounds good. We'll talk about it in more details later on. Perfect. All right. So there are basically two kinds of functions in each APIs for each of the functions we have described, starting with create, get details, or get data, set data. For all of these functions, there are two kinds of implementations. Okay, in each of these libraries. All right. Now, the watch triggers the whenever you are doing an operation such as exist, get data, get children, create data, In all of these cases, we can provide the trigger. We can say, does this node exist? And here is my watch trigger. As soon as so this watch trigger will be executed as soon as this node is created if it does not exist. In case it exists, if this node gets deleted or data of this node is updated. Your watch which you created while executing a function called exist, that watch will be executed as soon as this node, if it does not exist, it is created, or if it exists, it gets deleted or data gets updated. So those are the ways to do the watch triggers. Those are the times when a watch gets triggered. In case the watches of get data get triggered when the node is deleted or has its data updated. Okay, get children like ls slash we did. The watches will be triggered when the node is deleted, the node for which we did get children, or if any of the child is created or deleted, the that particular trigger will get executed. Okay. Now, access control list is something which determines who can perform what operation on this node. Okay, who can perform what operation on it. That is controlled by ACL, and it depends upon authentication. Authentication, there are three forms of authentication which Zookeeper supports. The first one is digest. Digest is simple one where user authenticates by login and password. This is the most simple one and most popular one. Second is SASL. When the client does not provide username and password, instead it provides the Kerberos token and says, I'm already logged in Kerberos and here is my token. Okay, here the user only provides once while the user is logging into the network, and it only provides the credentials once to Kerberos, and afterwards it doesn't. Okay, next is IP. So we say that this is a very safe network and anybody who is on this IP is okay to use all of these nodes or is authenticated. So all so basically there are three kinds of authentication which Zookeeper supports. And ACL is a combination of authentication scheme, an identity for that authentication scheme, and a set of permissions. All right. So ACL it has authentication, then authorization. Okay. Authorization is set of permissions. Now, with respect to the architecture of Zookeeper, there is a standalone mode. It is very only for testing purposes. The real one is replicated. So you might be thinking that Zookeeper it just runs on one machine. Zookeeper just run on single machine, but Zookeeper itself is like MongoDB or is a distributed service. There are multiple machines running the Zookeeper parallelly. Okay, this mode is called replicated. Standalone, there is only one machine running Zookeeper, but in a real scenario, the Zookeeper runs on multiple machines simultaneously, and that is the only reason why we actually are discussing Zookeeper in context with big data and Hadoop. All right. Now, so it runs on a cluster of machines called ensemble. All the machine you designate for running the Zookeeper are called ensemble, is highly available. It tolerates as long as there is a majority. Okay, it tolerates as long as there is a majority. The moment m- less than majority machines are down, it goes down. Meaning, if machines more than 50% are not up, meaning if 50% or more machines are down, if 50% machines are down, then also this cluster becomes read only. Zookeeper will become read only and will no longer function for writes. All right. So the other, another aspect of the architecture is there are two phases. One is leader selection. So as we told you that Zookeeper is essentially a bunch of computers running this Zookeeper service. Okay, these are the bunch of machines which are running the Zookeeper service. These machines together elect a distinguished member called leader. Okay, so unlike unlike our name node and HBase and all of this, where in case of name node, we basically ourselves designated one machine as name node. Here it's not the case. Here all these machines vote and select one node as leader. Others are called followers. The leader is the one which accepts the rights, while read while rest of the followers are only for reading the data. So whenever you want to write the data, you figure out which one is the leader and it starts writing the data. You start writing the data. In case in case you want to read the data, you have so many other followers who can basically provide you the data, right? They are only for reading the data. So the way it happens is initially when the system is coming up, they select a leader and others become follower. This phase is finished in when majority sync their state with the leader. Okay, so one leader was selected, rest of the nodes will synchronize their state from this leader. Now, in case this leader fails to respond to the user's request or something happens or there are chances of something happening, then leader steps down and remaining machines hold an election, and this process is, takes around 200 milliseconds. All right. So this is more like a democracy. In case all these machines vote and select the leader who is best responding to their pings. Okay. In case there is a machine which is not responding to the pings or is slow, that will not be selected. Instead, the one which is far more responsive will get the maximum votes and will win and become the leader. All right. So any machine in this ensemble can automatically become the leader. All right. Second is the atomic broadcast. All rights are forwarded to the leader. Leader broadcasts the update to all the followers, meaning the data is flowing from the leader to the followers. If you remember our NoSQL discussion, the central one where people are writing to one, reading from another, and the data is flowing from the node which is accepting writes to the other which are only for reads. And the when majority have persisted the change, the leader says that I have committed the data. Okay, and sends the response to the end user saying your data has been committed. Okay, so this protocol for achieving the consensus is atomic, meaning when you write the data, when you write the data and get the response, is fairly consistent. Okay. Also, you should note is that machines are, whenever write is happening, write happens to the disk first and then to the memory, meaning it is strongly persisted. All right. In case something goes down, one machine goes down, or there is a process goes down and you have to reload the process, then the data is not lost. All right. The architecture, the whatever we discussed in the previous screen, this is how it looks like. Sounds good. So there is a, these were three machines in our ensemble. These are the three machines in our ensemble. Okay. And in this ensemble, all right, in this ensemble there were three machines. All these three have decided to choose one machine as a leader. Now all the reads, this leader will respond to the writes, while it can also respond to the reads. Okay. So but generally the leader will be used for the writes. Okay. So if the client comes in and tries to talk to follower to write the data, follower will redirect the request to the leader. Now, few things you should note is, in case out of these three machines, one machine goes down, so 2 by 3 machines are available, which is more than 50%. 2 out of 3 are available, which are more than 50%, and hence this system will keep running. In case the another follower goes down, so in case either the follower, or say, imagine this one went down, this particular one. Okay. 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 So imagine that this one went down. Okay. This one went down, and let's just mark it like this. Okay. So this one went down, so it will keep running, the system will keep running fine. The moment this one also goes down, the leader will step down, because 2 out of 3 should be available. More than 50% votes should be available. Okay. So more than 50% should be available, otherwise the leader will step down. Or in case this goes down, the system will not choose this as the leader, because there's only one. The total number of votes which are available right now are less than 50%. Okay. Make sense to you? So in case this happens, there will be no leader, and the system will become read only immediately. Okay. So in case there are 10 nodes. So let me ask you this. In case there are 10 nodes in ensemble, and 3 nodes are down, will there be a leader selection? Anybody else? So in case there are 10 nodes in assemble, and the guarantee is there should be majority of nodes up. And what does it mean by majority? Majority means majority equals more than 50%, which is minimum, which is minimum 6 nodes, right? It will choose the leader, right? Now, now in the okay, that was my question number one. Now, next question to you is question number two. In case, in case five nodes are down, okay, but the leader node is not the is up, is amongst the node that are up. What happens? Anand says it will continue to be leader. Santana also they says zookeeper will fail. Good, thank you, Sergio. So basically, what will happen is the leader will step down, okay, and zookeeper will become read only. All right. Now, you might argue at this point that although we have five good nodes running, why don't we keep running? Why don't we just keep running? Five nodes are good enough, right? Five nodes. Because of this stepping down and this logic, this weird logic that there should be more than these many nodes, why are we compromising on availability? Can anybody answer that? Here, stepping down, stepping down may go up to one. I did not get this one. Yeah. Okay. Okay. So Anand mean to say is that it should not have a step down. Probably this is what you're saying. Yes. Yes. So in case whatever nodes are available, zookeeper let it run it. Unless and until all nodes are down, let it run it. Why is this weird rule that there should be 50% of the nodes only up, at least 50% of the 50%, more than 50% nodes up, only then there will be anything zookeeper will do. Otherwise, it will just become read only. Why is this weird rule? It is due to high availability. Yes, I want to understand that. If we were so much inclined to have the high availability, we should actually keep running five, right? Rather than making everything stop the moment sixth one went down, everything stops. There is no leader. If there is a leader, it will step down and will say that this ensemble cannot run. If we were so inclined for high availability. If you are to design this kind of system, wouldn't you say that whatever nodes are available, let there be a leader? Even if there are three nodes available, let there be a leader and let them select a leader. Let them keep writing the data. Don't you think that's what you'll do? Why would you have this kind of weird rule that there should be 50, more than 50% nodes available? Only then there will be a leader selection. Anyone? Are you okay with this kind of approach? Are you okay with this kind of approach where you have more only the whole cluster will run if there are more than 50% nodes available, right? It actually sounds very, very strange that I had 10 nodes, I lost 5 nodes, at least let these 5 nodes run before I bring up my other 5 nodes. Okay. So why do you think there is such a rule? Is the question clear to everybody? Does anybody find it strange? Mark's point is that so that way there is always the availability for spillover. No, I did not get this one. Shouldn't it continue running even if we have 5 nodes? Why should it just drop everything, stop everything if we have less equal to or less than 5 nodes out of 10? Anybody? And for those who are thinking that it is strange only with Zookeeper, it's true in everywhere. MongoDB follows the same principle. In MongoDB also there is a leader, there are followers, and leader selection can only happen if there are more than 50% alive. Anyone? This is called gossip protocol. This is a part of the gossip protocol. Will This will violate the rule of 50%, but I want to understand why is this rule in the first place? There must be some reasoning, right? Why did we? Because in any democracy, okay, Anand says so it is still considers 10 nodes. Let me copy. So this is what he has written. Anand says so it is still considers 10 nodes, or all fail nodes will be ruled out. Okay, distribution need to be even but still have a leader, meaning if 5 nodes go away, then out of 5 voting starts, which is again 100% at most. Four leaders in the cluster. Okay. No. So if five nodes have gone away, we'll have to bring down the cluster and say that there are only five nodes available right now, and let's restart the cluster. We have to tell explicitly that we know that there are only 50, these many nodes left. Okay, we have to tell it explicitly. Same is the case with MongoDB. All right, so let me answer it. It took me some time to figure that out. Yeah, so it took me some time to figure that out. So let me just go through a couple of slides. So if there was a leader A, leader got shut down, what will happen next is, you have already answered this question, either B or C will become the leader. This is perfectly fine because 2 out of 3 is more than 50%. Next is, in case A and B went down, C, who was already a leader, will step down. Okay, C will remain the follower. Okay, if C was the leader and or B fell down here, if A shut down, C became the leader, then B was shut down, no one will become the leader, C will become followers. Okay, because majority is not available. Next is, so my explanation to you is that imagine that the ensemble is spread over two data centers. Okay, you have, imagine this, imagine this, imagine this. You have A, B, C, D, E, F. There are total number of 6 nodes. Okay, there are total number of 6 nodes. Is it visible to you? Okay, there are total number of 6 nodes, and 3 nodes are in one data center, 3 nodes are in two data center. Now imagine that if we did not have this 50% rule and this happens, the cord between the two data centers get disconnected. Okay, in case this happens, if we cut the cord between the two data center, what will happen? Okay, so there are 3 nodes this side, 3 nodes this side, and if we did not have this 50% rule and we said whatever nodes are available, select a leader and keep working. In that case, data center 1 will choose its leader and data center 2 will choose its leader. There are now two leaders accepting the rights from various clients. Some rights are going to this leader, some rights are going to other leader. The whole premise of consistency failed pathetically. Why? Because there are now two leaders. And why there are two leaders? Because we allowed the two partitions of our network to choose their leader, right? Okay, so okay, so in case you are a very finicky kid, okay, let me give you an analogy why with this 50%. You are a very, very finicky kid. In your birthday, you always want that I should get the biggest piece of cake out of all the guests. Okay? Out of all the guests, you should always get the biggest piece of cake. How do you ensure that? you ask for bigger piece than 50%, right? That way nobody else in the whole party will get bigger piece than you in of that cake, because there can be only one piece of the cake which is bigger than 50%. All right. Therefore this rule comes in that if there are more than 50% available, there can be only one leader, no matter how the partition happens. Either there will be no leader at all, or there will be only one leader in case the this kind of partitioning of the network happens. Sounds good? Okay. So to avoid anybody else get, be, gets the bigger piece of cake, you make sure that I should get more than 50%. Okay. Same way is with the leader selection. We make sure that if we make this rule that only if there are more than 50% nodes available, there is a leader. Otherwise, there are no leaders. Okay. So yeah. So if data center 1 has 50 nodes and center 2 with one node as the leader, so how many total nodes are there in data center 2? Only one node. Okay, so there are 51 nodes in total, and in case this wire get disconnected between data center 1 and data center 2, what will happen is somebody from data center 1 will become the leader. All right. Although although a node which is closest to all other nodes generally becomes the leader because he gets the maximum number of votes. All right, sounds good to you? Any questions? So an ensemble of 10 nodes can tolerate a shutdown of how many nodes? 6 nodes. 4 nodes shutdown. Yeah, 4 nodes. Okay. So there has to be 6 nodes for the selection. All right. Now there are various kinds of and somebody's question is still pending. Why do we need ephemeral nodes? We will answer that. So these are the various guarantees provided by Zookeeper. First is sequential consistency. Second is atomicity. Third is single system image. Fourth is durability. And sequential consistency is updates from a one particular client are always applied in the order. Second is atomicity. Either either the updates fail completely or all are successful. Third is single system image. The user, the client will always see the same image no matter what. Okay. The new server which is coming up will not accept connection until it has caught up with the latest data. Durability. Once an update has succeeded, it will persist and will not be undone, because only after persisting it is available into the memory. It is written first and read late and loaded later into the memory. while in most of the cases it's generally inverse. We put it in the memory and then we put it in the disk. Like for example, in case of MapReduce, the results of at the mapper level, all the results were put into the memory and then were persisted into the file system. Rather than allowing a client to see very stale data, a server will choose to shut down. That's more like a suicide from the zookeeper side. Yeah. So Santhana's question is, when the connection between get disconnected, how will the data get synchronized after the connection is restored? If some write operation has happened during that time. So as we talked about, every node maintains the version number count in a sequential manner. Every node contains that number. So an older node, a node containing older state, will have a smaller version number, while the node containing the latest version will have bigger bigger version number. Okay, based on that, it will so the node with a smaller version will synchronize the data from the node with the higher version. All right. Yes. All right. So there is a concept of sessions, a client, and the way this is very important to understand, and because that's the same mechanism used everywhere where this kind of a automatic selection of leader happens. A client has a list of server in an ensemble. Client meaning you who wants to use Zookeeper. You, as in your library, will have the list of servers in the ensemble. When you start, you will get the list of server. You'll have to specify to the client that these are my machine names in the ensemble. And whenever you do an operation, say, get me all the nodes, it will start with one node and will keep trying until it has exhausted all the nodes, all the list of the server. Okay. As soon as the connection is successful from the client, it creates a new session, and the session has got a timeout period, which is decided by the caller. Okay. If the server hasn't received a request within the timeout, so whenever your library is connecting to the server, it will also tell that this is the timeout period I'm looking for. Okay, and if the server does not receive any request, or there is an idle scenario and for more than the timeout period, the session will expire. And if the session expire, all the ephemeral nodes are lost. To keep the sessions alive, client continuously keep on sending the pings, which are also known as heartbeats. The client library which you are going to use is going to take care of heartbeats. It will underneath the client will continuously keep on sending the heartbeats. Okay, so that the server does not, Zookeeper does not expire your session. Okay, sessions are valid. Sessions are still valid if you are switching to another machine. So you created a session. This client is continuously sending pings to the server that I'm alive, I'm alive. In the meantime, server shut down. And there is another machine now client will automatically connect to. That does not mean the session will expire. Why? Because the client is awake and the session information is propagated to other machines also. So all other machines in the Zookeeper ensemble know this client. All right. Now application can, though from the surface it looks like that all this session management and the is client library is automatically switching between multiple machines as the machines are shutting down and coming up. It does not mean that your application is completely totally agnostic about this kind of failure. Reason being, if one client has got disconnected and is in a process of connecting to another node, in this duration your update, your commands might fail. Your get data, ls, or other commands might fail in this time. So your client library, when you write the program, you should be at least retrying multiple times. All right. Now somebody was saying that what's the point of ephemeral nodes, right? The ephemeral nodes are very important in case of load balancing. In case of load balancing, all right. Now imagine that there are hundreds of servers and millions of clients. Hundreds of servers and millions of clients. Okay, these millions of clients have to find out which are the servers available, and they will connect to any of the server which is available quickly. All right. So, and these servers, some of them might shut down in between, some of them would be up, and some of them might get shut down, and new servers might get added. Okay, so either each of these millions of clients are keeping track of all the servers all the time, or the other way could be that these servers give their attendance to zookeeper in the form of ephemeral nodes. Okay, so imagine that each server creates an ephemeral node onto the zookeeper, and as soon as this server goes down, the ephemeral node disappears. So that, and this, what does this ephemeral node has? The IP address of the server which is up, which means zookeeper, this particular node, z node, will have only the subnodes for the servers which are up. Okay, so the clients, if they just take the listing out of these servers which are up, that should be good enough. Sounds good? No? Because client cannot keep tracking. Client can just start using zookeeper, and as and when these servers are coming up or going down, their nodes are disappearing. These clients will just keep on seeing this particular node, what are the various childs available, and will connect to any of those. Okay, so this kind of coordination, the headache of the coordination, is very well taken care by zookeeper. Sounds good? All right, you can have a look at this diagram. So here, this is the zookeeper, this is the client, this is the server. Server connects. Okay, server connects to the zookeeper and says that, okay, and this zookeeper replies it saying, okay, I'll call you when needed. And each server gets the watch event from the zookeeper and so on, right? Now after some time another node comes up. It creates its ephemeral node called duck, and another server comes up called cow. Now when the client comes up and says, give me the listing of servers, it will tell that duck and cow is available. After 5 seconds, here let's say the duck server got down, which means this machine got down, which means the ephemeral node disappears. So there will be no duck in the server's list. Okay, which means if after some time the client comes along and says ls less server, there will be only cow available. Okay, so this way the discovery of available server becomes very automatic and simplified. All right, so hands on you can basically try to do this. We have already done all of this. You should try to do all of these commands. There are many use cases of service like Zookeeper. HBase uses this to communicate with region servers, and region servers uses Zookeeper to talk to HBase and get themselves discovered by HBase, and also coordinate between other region servers. So similar to HBase, there are other more services which relies upon things like Zookeeper to solve the problem, such as the lock service, such as configuration service. Okay, any questions here? Sounds good. Yes, so all the things which I try to do, create node, then create ephemeral node, create sequential node, deleted some of the nodes, or just you open 5 6 sessions and create one ephemeral node from each session, and then try disconnect it and see has the node disappeared or is it there still. It takes around 5 seconds for that. All right, now you must try it out by yourself. All you need to do is start by going to the command prompt and saying zookeeper client, and you have this. Okay, all right, we have around 20 minutes, so we will start with the introduction of rest of the sessions. All right, so the session 9 is about four things. One is scoop, then flume, then Uzi, then Mahat. These are very important services, just that you just need to know few commands to get started with them. All right, so we'll go through these tools very briefly. So there is this command called scoop. Scoop is a command line utility. It doesn't have any server or anything. All it does is it copies the data from structured sources. I will show you. And okay, so imagine that we have HBase, we have Hive, and we have Hive HBase HDFS, and on the other side we have relational database. So okay, so basically basically here, using a scoop, you can import data from relational database. This is import, this is import, and this is import. So you can import data from relational database into HBase, Hive, or HDFS. Okay. Similarly, you can export data from HBase to relational database, to from Hive to relational database, from HDFS to relational database. Okay. So although this does not make much of a sense from HDFS to relational database because it's just a file, Okay, now you can see that these all six are very easily possible using Scoop. All right, that's what it does. So Scoop is essentially the data movement tool from Hadoop to any relational database. Okay, you can you can keep basically it also has extension framework called connector. So in case your database is not supported, so this database just need to have a JDBC driver. That's all. If we have a JDBC driver for this database, we can use Scoop for translating, moving the data back and forth. If the driver is not available, it's pretty easy to create a connector, and you can use that connector for the import and export. All right. The command is fairly simple. It looks like this. You log into the server here and say scoop, and it says scoop help, gives out that these are the main commands, and we will be focusing on import and export and import. All right. And in case you want to see specifically, you can say scoop help import, and it'll give you more details. All right. Now there are scoop connectors. A scoop connector is a modular component that uses the extension framework to enable scoop import and export data from any data source. So as we have already talked, the since the JDBC connector is available for almost every database, you will never get into the situation that you cannot use Scoop with your structured data, because there is JDBC connector for almost every database. If there is no JDBC connector for your database, you are definitely living in a different world. Now, for the example case, let us log into our MySQL. Okay, this is our MySQL. And first, let's create the database. Before that, we'll just drop the database, scoop ex3. So we have just deleted a database. Let's just create the database. Now here you should note database create this database we are creating. Why? Because we want to give you a demo. So we will put some data in MySQL, and then we will import this data into HDFS. So we need to create some dummy data. That is why we logged in into MySQL, and in that we are trying to create a table. All right. So let's create a database table. Now, a few things to note. By default, when you create a database in your by default when you create your database in MySQL, the database will only available locally, right? But if you know the scoop part, whenever you say scoop import or export, it basically uses map reduce to distribute the work of import to multiple task trackers. There will be hundreds of task trackers which will start pulling the data properly from a table into Hadoop. Okay. Therefore, it is important that your MySQL should be allowing the connection from other nodes as well. And this is where most of the difference lies between the virtual machine and the real cluster. On the virtual machine, your all of this import export will perfectly work. But when it comes to the real scenario, where there are multiple machines and those machines are not allowed to access the database, your import export will fail and you would be wondering what is wrong with my approach. All right. Therefore, we are trying to give privileges on scoop x3 to all these nodes properly. All right. Makes sense to you? Because in the beginning, when I was trying to set up, we all faced this issue that how come this import is not working. Sometimes it was successful, we were pretty happy. In those times, what exactly happened was the import happened on the task tracker. The MapReduce ran on the task tracker called Hadoop one, or same machine as the one which is running MySQL. So we were fooled into thinking that, oh, this is working fine. It is just that sometimes it doesn't work. But the reality was, the times it did not work were the times when the MapReduce were launched on different machines than MySQL, and because of the database connectivity issues, it did not work, because by default a database does not allow the access from the remote. All right, keep that in mind whenever you are. And now let's create some dummy data. Okay, let's create some dummy data. So we created a table. We say use scoop ex3, and then we create the table. We say select star from widgets, and we have this table. We want to import this first into HDFS. So to import this into HDFS, let's just create one more session here. This is MySQL, and let's go to scoop. We say scoop import connect to my MySQL and provide the host name of the MySQL along with the database name, and then say that extract table and number of total map is 1 and username is this and password is nothing, and there we go. So this essentially will create a file called widgets under which the data will be saved. Okay, so it has finished importing the data, and let's see, it says that it has finished. And okay, we can say Hadoop fs minus ls and say widgets. So this is the folder that contains our output part m. Let's see what is there inside it. You can see that, so it got imported from our MySQL to here, right, with a comma separated format. So you did not have to write your Java program to connect to via JDBC to the database and pull that and put it into HDFS. Instead of that, you were able to successfully run Scoop. All right. Also notice that here there is a class called java.this. In case you have to frequently keep doing import all the time, you can basically compile widgets.java and use it. This is the mapping between the two and has all the logic to move the data from one to another, and this will serve as a great ORM for you. All right. Next is, let's import this data into Hive. So while to import the data into Hive, you need two more things. First, you need to create the database table in Hive. Then we say load my data from HDFS into into the Hive table, right? So let's just create a table. So instead of you writing create table, all these columns, Hive can create the table based on the table defined in MySQL. All you need to tell is scoop, create table, this is my MySQL URL, this is the table name, and and fields are terminated by comma, and these are the login and password for my MySQL. Now this will create a table, right? Now inside Hive, it has created the table. We will have to create one more session that will run only Hive. So we can see inside Hive, okay, we can see that there is a table called widgets, and we can see select star from widgets. There is nothing inside widgets table, right? For doing that, we'll have to load the data in the path called widgets into widgets. Okay. Now, if you say select star from widgets, the data has been loaded. So now, if you notice keenly, there are three steps in this. First was taking data from MySQL to HDFS. Second was to create Hive table. Third was to load the data, right? If you want to do all of this in a single shot, you can do it very easily. First, let's drop table widgets, and in a single step, let's do it. So what does it say? It says the folder already exists. Let's drop this folder. Say Hadoop FS RM R and widgets. Alright. Now let's execute the command again, which will do all these three steps in a single shot. Alright. Alright. So the table is done now. It has been loaded. Again, you can see the data is there, right? Not here. Sorry, I'm extremely sorry. Here, we can say select. Oh, I think I've deleted it again. Okay, we'll have to do these few things. All right, let it finish. Still, all right, this will now finish. Let's just, okay, here. Now the data has come. Fine. So in a single step, all of this was done. Next is in case you want to create a table in HBase. Okay, let's call it customers just to avoid any kind of conflict with the older tables. Okay, so we can directly, the way we imported data into Hive, we can also do the same thing with HBase. All we need to do is scoop, import, provide the URL of our MySQL, provide the name of the table, and HBase table is customer. From widgets, we are trying to send it to customer. And as you remember that in case of HBase, we do require a column family. So you can specify the column family you want. Also, the column names you can specify in the command line argument. And then login password of MySQL, and the main command is hbase create table, not here, on the command prompt. All right, so it started the import to hbase, and in parallel here let's start hbase shell and see if a customer table is created or not. We can say list, and we can say scan what is customer. Customer is here. So it has all the columns. Each row ID has is ID column has automatically become the row ID, and there are various columns: CF1 column design comment, CF1 design date. All of this part of the same column name, same column family name, CF1. All right. That way we are able to import the data from HBase into. So we are able to do. So this is done. Okay, so we were able to bring data from relational database. We were able to bring data into Hive from relational database. We were able to bring data into HDFS. Now these two are remaining. We will we will focus on getting data from HBase into relational database and Hive into relational database. Okay, we'll talk about it in the next session. All right, now we will try to import the data, which is this one, from Hive to MySQL, Hive to MySQL. All right, sounds good. All right, let's continue from here in the next session. All right, great. So I hope you are having good time. Are able to understand whatever we are discussing here. And All right. So feel free to refer your friends for our next sessions in case you like our sessions. All right. See you on the next weekend. Thank you very much. Bye Santana. Bye Anand. Bye Sarju.